On July 1st, 2025, astronomers in Chile detected something extraordinary, a faint speck of light moving through space at over 150,000 miles per hour. But this wasn't just another comet. The trajectory revealed something shocking. This object didn't come from our solar system. It came from somewhere else in the Milky Way galaxy. On December 19th, it made its closest approach to Earth. We call it 3I/ATLAS, the third confirmed interstellar visitor to pass through our cosmic neighborhood. And what scientists discovered about this ancient traveler has rewritten everything we thought we knew about the chemistry of other star systems. But there's something else. Within hours of the announcement, conspiracy theories exploded online. Some claim this wasn't a comet at all, but an alien spacecraft deliberately entering our solar system. So what did we actually find? What secrets does this interstellar visitor carry? And perhaps most importantly, did we just miss first contact? The Atlas telescope system wasn't designed to find interstellar objects. Its mission is far more urgent: to detect asteroids that could threaten Earth. 4 robotic telescopes, scanning the entire night sky every 48 hours, searching for anything that moves. But on that July night in Chile, the automated system flagged something unusual. A faint object, designation C/2025N1, moving faster than anything should. The preliminary data didn't make sense. Most comets follow elliptical orbits, bound to the sun's gravity. But this trajectory was different. It was hyperbolic, meaning this object wasn't orbiting anything, it was passing through. Within hours, astronomers around the world began hunting through archived images, and they found it. The Zwicky Transient Facility had captured it weeks earlier, on June 14th. It had been there all along, hidden in the dense star fields of the galactic center. Pre-discovery images revealed something remarkable. This object had entered our solar system from a region of space no human-made probe has ever reached. To understand why this discovery matters, we need to go back to October 2017. That's when astronomers detected Oumuamua, a strange cigar-shaped object tumbling through our solar system. It was the first confirmed interstellar visitor in human history. Scientists scrambled to study it, but within weeks, it had already passed Earth and was racing back into deep space. We missed our chance. Then in August 2019, we got a second opportunity. Comet 2I/Borisov appeared, and this time we were ready. Multiple telescopes tracked it for months, revealing it was surprisingly similar to comets from our own solar system. But it raised more questions than answers. Now, 3I/ATLAS gives us a third chance, and the timing couldn't be better. Unlike Oumuamua, which was already leaving when we found it, 3I/ATLAS was discovered early, while it was still approaching the Sun. This gave scientists months to prepare. NASA's Hubble Space Telescope, the James Webb Space Telescope, the Parker Solar Probe, even the Europa Clipper spacecraft, all turned their instruments toward this cosmic traveler. Because every interstellar object we study teaches us about star systems beyond our own, about how planets form around distant suns, about the building blocks of worlds we may never reach. So what did all those telescopes find? The answer surprised everyone. When the James Webb Space Telescope analyzed the light coming from 3I Atlas, it detected something unexpected. The comet was unusually rich in carbon dioxide. In fact, it had more carbon dioxide than water ice. That's bizarre. Most comets in our solar system are dominated by water ice with some carbon dioxide mixed in. But this visitor had the opposite chemistry. JWST also detected carbon monoxide, carbonyl sulfide, and traces of water vapor. Meanwhile, the Very Large Telescope in Chile found something else: cyanide gas and atomic nickel vapor, the same chemicals found in solar system comets, but in different proportions. Then came an even bigger revelation. By tracing the comet's trajectory backward through space, astronomers determined where it came from. Not the thin disk of the Milky Way where our sun lives, but possibly from the thick disk, a region of older stars that formed earlier in our galaxy's history. If that's true, 3I Atlas could be over 7 billion years old, older than our entire solar system, older than Earth. This object may have formed when the universe was barely half its current age. It's a frozen time capsule from the ancient galaxy. The observation campaign for 3I Atlas was unlike anything attempted before. Because we had advance warning, NASA coordinated an unprecedented effort. The Hubble Space Telescope was first. On July 21st, just 3 weeks after discovery, Hubble captured detailed images from 277 million miles away. The images revealed a teardrop-shaped coma surrounding the nucleus. Hubble's continuing observations allowed astronomers to narrow down the comet's size. The nucleus had to be somewhere between 1,400 feet and 3.5 miles across. Small, but incredibly active. Then, the James Webb Space Telescope took over. Infrared instruments could see through the dust, detecting the molecular composition of the gases streaming off the comet. That's how they found the carbon dioxide dominance. But the most dramatic observations came from an unexpected source. NASA's Parker Solar Probe, designed to study the Sun, was in the perfect position. From October 18th to November 5th, Parker captured images of 3I Atlas as the comet passed behind the Sun from Earth's perspective. Parker saw what no ground-based telescope could: the comet's interaction with the solar wind, the formation of its tail in real time. Even the Europa Clipper spacecraft, on its way to Jupiter, turned its instruments toward the visitor. On November 6th, from 102 million miles away, Europa Clipper's ultraviolet spectrograph detected oxygen, hydrogen, and dust in the comet's tail. Every spacecraft, every telescope, contributed a piece of the puzzle. But the discoveries didn't stop there. On December 3rd, the European Space Agency's XMM Newton Observatory did something remarkable. It observed 3I Atlas in X-ray light. For 20 hours straight, XMM Newton watched as the comet emitted X-rays extending 250,000 miles into space. That's more than the distance from Earth to the Moon. But here's the thing: comets don't naturally produce X-rays. They're cold chunks of ice and rock. So, where were the X-rays coming from? The answer lies in a phenomenon called charge exchange. As the solar wind slams into the comet's coma, highly charged ions strip electrons from neutral gas molecules. That violent interaction releases energy in the form of X-rays. It's like watching an invisible collision happening in real time. The X-ray glow revealed something else. 3I Atlas was outgassing more intensely than expected. After passing closest to the Sun on October 29th, the comet experienced a surge of activity. The heat from its solar approach triggered massive releases of gas and dust. Scientists detected this burst through multiple observations. The ultraviolet spectrograph on Europa Clipper saw it. Ground-based telescopes measured it. Even amateur astronomers reported the comet brightening unexpectedly. This wasn't just a passive chunk of ice drifting through space. This was a dynamic, evolving object, actively responding to the Sun's energy. And it raised a fascinating question. If this comet survived 7 billion years in the frozen darkness of interstellar space, how did it remain so volatile? What kept it from losing all its ices during that impossibly long journey? Now let's talk about the elephant in the room, the alien spacecraft theory. Within hours of the announcement on July 1st, 2025, social media exploded with claims that 3I Atlas wasn't natural. Some pointed to Oumuamua's strange acceleration in 2017 as evidence that interstellar objects might be probes. Others noted the unusual trajectory, the perfect timing of the discovery, the coordinated observation campaign. Surely, they argued, this level of scientific interest meant something was being hidden. But here's what the conspiracy theories miss. Scientists were excited precisely because this is natural. Because studying natural interstellar objects is incredibly rare and valuable. We've only confirmed 3 in human history. Each one is a scientific treasure. The chemistry alone disproves the artificial hypothesis. 3I Atlas is shedding cyanide, nickel vapor, carbon dioxide, and water. It's outgassing like a comet because it is a comet. The X-rays? That's charge exchange, a well-understood phenomenon observed in other comets. The unusual composition? That tells us about a different stellar environment, not alien engineering. But here's why the theories persist. We're pattern-seeking creatures. An object from another star system entering ours feels significant. It should mean something, right? And in a way, it does. Just not the way conspiracy theorists imagine. This visitor tells us that the galaxy is full of wandering comets, that planetary systems eject material all the time, that we're connected to the broader cosmos in ways we're only beginning to understand. That's actually more profound than any spacecraft theory. So what did we actually learn from 3I Atlas? First, interstellar comets have different chemistry than we expected. The carbon dioxide dominance suggests formation conditions we don't see in our own solar system, perhaps around cooler stars, or in regions with different carbon to oxygen ratios. The thick disk origin adds another layer. If 3I Atlas really is 7 billion years old, it formed when the galaxy looked very different. Star formation was more active. Heavy elements were less abundant. The chemistry of the early galaxy may be literally frozen into this comet's nucleus. Second, we learned that interstellar objects are more common than we thought. Before 2017, we had theories. Now, we have data. 3 detections in 8 years might not sound like much, but remember, we're only just beginning to look. The Atlas system that found 3I Atlas wasn't even designed for this. Imagine what we'll find with dedicated surveys. The Vera Rubin Observatory, which begins full operations in 2025, will scan the entire southern sky every few nights. Scientists predict it could detect dozens of interstellar visitors per year, maybe hundreds. Third, we learned these objects survive incredibly long journeys. 7 billion years in the radiation of interstellar space. Cosmic rays bombarding the surface. Yet, 3I Atlas arrived with enough volatile ices to create a spectacular coma and tail. That tells us something about how ices are preserved in deep space, about insulating layers of dust, about the physics of sublimation at near absolute zero temperatures. Every answer creates 10 new questions. 3I Atlas is already gone. On December 19, 2024, it made its closest approach to Earth at 168 million miles. Now, it's heading back out into interstellar space, traveling at over 150,000 miles per hour. By early 2026, it will cross the orbit of Jupiter. By 2030, it will pass Neptune's orbit, and then nothing. Back into the cosmic dark, never to return. We had our window, and we used it well. But the story doesn't end here. In fact, it's just beginning. The Vera Rubin Observatory is about to change everything. Starting in 2025, its legacy survey of space and time will discover thousands of new objects every single night. Asteroids, comets, distant galaxies, supernovae, and yes, interstellar visitors. The survey's speed and sensitivity mean we'll detect these objects earlier and track them longer. We might even catch some on their way into the solar system, giving us years of warning instead of weeks. NASA is also developing rapid response observation protocols. When the next interstellar object appears, we'll be ready with a coordinated campaign from day one. And there's talk of something more ambitious. An actual mission to intercept an interstellar visitor. Not just observe from a distance, but send a spacecraft to rendezvous with it, to study it up close. Maybe even return a sample to Earth. It sounds like science fiction, but the technology exists. We've rendezvoused with comets before. The challenge is the speed and the trajectory. Interstellar objects move fast and don't come back for a second chance. But imagine what we could learn from a few grams of 7-billion-year-old ice from another star system. That's the future we're building toward. Let's step back and look at the bigger picture. For billions of years, objects like 3I Atlas have been passing through our solar system, long before humans existed, long before Earth had life. These visitors have always been here. We just didn't know to look for them. And they're not just passing through our neighborhood, they're everywhere. Right now, at this very moment, thousands or millions of interstellar comets are crossing through our solar system. Most are too small or too dim to detect, but they're there, invisible messengers carrying information from distant star systems. Think about what that means. Every star system in the galaxy is exchanging material. Comets ejected from one system eventually wander into another. The galaxy isn't a collection of isolated islands. It's a connected web. Material, chemistry, maybe even the building blocks of life, spreading from star to star over cosmic timescales. Some scientists have even suggested panspermia, the idea that life's precursors could hitch rides on interstellar comets. We don't have evidence for that yet, but we do know these objects carry complex organic molecules, carbon compounds, the chemistry of life, and the numbers are staggering. Recent calculations suggest there might be more interstellar objects in our solar system at any given time than objects from our own Oort cloud. We're literally swimming in material from other stars, and we never knew. 3I Atlas reminds us of something important. We are not separate from the galaxy. We are part of it, connected to it through gravity, through chemistry, through the wandering ice balls that cross between the stars. Every time we study one of these visitors, we're reading a message in a bottle, tossed into the cosmic ocean billions of years ago, and we're only now learning to read what it says. Thanks for watching. If you want to explore more mysteries of space exploration, subscribe to Orbital Atlas and hit that notification bell. The universe has more secrets to reveal.